Welcome everyone. So today we are looking at Leetcode number 5, longest palindromic substring. Okay, so we have a prompt here. Given a string S, return the longest palindromic substring in S. So here we have a string BABAD. Our longest palindrome is BAB or ABA. Here we have example 2. We have S is equal to CBBD, and our output is BB. Example 3 is A. Any one character is also a palindrome, so the output is A. And then example 4 is AC, and it can be A or C. Okay, so what we want to look at is there's one thing we want to take a look at is consider here is that there is a constraint that we're always going to be given at least one character. So that's something we want to keep in mind when we start building a mental model about this problem. So let's go over here in our conceptual overview, and we can see here is that we have a string BABAD, and we have two outputs, BAB or ABA. And so there's two ways we can do this. We can implement a brute force solution where we get every single substring and then check if each one of those substrings is palindrome. And we can kind of go over the drawbacks of that. Or we can use a different approach where we go through each character and then find the longest palindrome by moving from the center of that character. Okay, so first let's go over the brute force. If we wanted to do this question brute force, the most obvious way to do this would be to get all the substrings first. So we can get substring B, BA, BAB, BABA, BABAD. Okay, and then when we can go to the next character and get all the substrings starting at that character, so we can do A, AB, ABA, ABAD, and then we can get the substrings from the next character. So here we're starting at B, we're going to go to A, now we're going to go to B here. We'll do B, BA, BAD, and then here we'll go to A, AD, and then we'll go to D. Okay, and so this is one way to do it. The issue is that we are going to have O of n squared to get all these substrings. And then what are we going to have to do? We're going to have to then check if each one of these substrings is a palindrome, which is another O of n operation. So our time complexity here is going to be O of n cubed. Okay? And our space complexity is going to be O of n squared. So it works, but can we do better? That's a question we need to ask with this problem. Could we do better? And the answer is yes, yes we can. So let's take a look at a different way of doing this. Let's say we have string S here, which is going to be BABAD, BABAD, okay, and we want to get the string either BAB or ABA. Okay, so let's say we iterate through each character and we check and we go outside. So each character is the first character, and then we're going to go from an inside out approach. So let's say we have the string BAB, we're going to start at character A and then move outward and check, is that a palindrome? Then move outward and check, is that a palindrome? And move outward and check, are those palindromes? And in that way, we can, once we move out to the maximum character that is a palindrome, we can deduce that that is in fact the longest palindrome. The other way to get a palindrome is another way to do it is the outside in. And that is where we start at the outside, so the first character of the string and the last character of the string, and check if they're equal. And we move from the outside in. Here we want to go from the inside out. Okay. So with palindromes, there are even palindromes and odd palindromes. Okay, so we can have an odd palindrome or we can have an even palindrome. And what is the difference here? An even palindrome is going to have it's going to have a single character in the middle. I'm sorry, an odd palindrome is going to have a single character in the middle, but every other respective character as you move out has to be the same. An even palindrome, let's say we have a string here. I believe we had CBBD. Okay, so let's say we have this string CBBD. When we get to this character here, we need to check what is behind it. Okay, and if those two characters are the same, then we can go ahead and move out, and everything else also has to be the same to get the longest palindrome. So that's what we want to do, is we want to go ahead and get our odd palindrome, okay, and we can just do a helper function. So let's say we do a function called get drome, and we do so if we're here and we want to get the odd palindrome, we want to get, if this is I, we want to set the start at I-1 and the end at I+1 and our string. If we want to get the even one, then we can do get drome. Okay, and we want to get I-1 and I and the string. What we want to do then is we want to check, because we want the longest palindrome, we want to check what is greater than. We want to get the max of even or odd. Okay, so this will give us our current max. And then we want to have a running max, a total max. And this is just going to equal the max of our current max and our total max. Okay? And that's the algorithm. That's pretty much it. The key here is that you want to think of getting the palindromes from the inside out, and you go through each iteration. So what's our time complexity here? Well, our time complexity is going to be n squared. O of n squared is going to equal our time complexity, because for every ith element, the worst case, we're going to have to go n times for every ith and we're going to have to iterate through each single I element. So the worst case is going to be O of n squared. What's our space complexity here? Well, we have to create space, but we're just creating a running max, which is just going to be a duple, but we do need to return the longest palindrome, not the indices. So our space is going to be O of n, because worst case, the entire input string n could be a palindrome, and we would have to return that. Okay, so let's jump into the code. Okay, we're going to jump right over here. So let's see here. First, we want to go ahead and create a result, or we want to create a running max. And we can set that to 0 and 1. And why do we set that to 0 and 1? Because here we can see a constraint that we're always going to have one character. That means that the worst case, or the base case, is going to be 1. We're going to at least have one character, and one character is a palindrome. So here at the end, we can return s.slice of max 0 and max 1, the start and the end, and that's going to slice it out. If there's no palindromes in the string, then the first character will in fact be the longest palindrome. Then we're going to go ahead and iterate through our s string. So for let s equals 0, it's less than let I equals 0, I is less than s dot length, I plus plus. Okay, and so now what do we want to do? We want to get the even and the odd palindrome, and then we want to calculate what's bigger out of that and get a current max. Okay, so we can just, we'll do a helper function, and we'll write this out in the end. But we can say let even equal get drome. And for our even, we want to check if the current, we want to get the current character and the character previous. So we want to do I minus 1 and I and s. And then we want to get the odd, which is going to be get drome. And this is going to be, we don't want the center character, we want the character previous to where I is and the character forward to where I is. So we're going to do start at I minus 1 and end at I plus 1. We should probably call these left and right instead of start and end. Okay, and now what we want to do is we want to get a current max. So we can say let current max, which is going to be our, if our odd end, or our odd of left, sorry, our odd of right is minus odd of left is greater than even of right minus even of left. If that's true, then that means odd is the greater max. So we return odd, else we return even. Okay, and then what we want to do, just like we figured out right here, we just want to update our total max here. So we want to go ahead and get our, update our max. So we can do max is going to equal max index 1 minus max index 0 if that's greater than cur max index 1 minus cur max index 0. Then what we want to do is we want to go ahead and return our max, else we want to update it with cur max. Okay, and then all we have left to do is go ahead and create our helper function. So we can do const get drome. And what are we going to have here? We're going to have our left, our right, and we're going to have our string. All right, and so now what do we want to do? We want to check if the left or right are out of bounds. Okay, so while left is greater than or equal to 0 and right is less than s dot length, we want to keep on moving outward. Okay, and if s of left does not equal s of right, then what do we want to do? We want to break out of this loop. And then what we do here is we just go ahead and decrement left because we're moving out, and we increment right. Okay, and then what we want to do here is we want to return, because we're going and putting in an extra character into the input. So what we want to do here is we want to just make sure that what we return here is left plus 1 and right. Now right is fine because when we use this slice method here, slice is not inclusive of the last index. So if this is 0 and 1, slice is just going to go ahead and return the 0th, the string or the character at the 0th index. It's not going to include that first index. And so that's why we don't need to decrement right here, but we do want to increment left or we're going to get the wrong indices. Okay, so we can go ahead and run this, and it looks good. Okay, so that is Leetcode number 5, longest palindromic string. Hope you enjoyed, and I will see you on the next one.